Alright, so now example 3. We're going to do the same thing we did on the first 2 examples, except for this time we now have some trig functions. I've got a cosine and a sine that we're going to use. Alright, so we're going to do, when we go through the part of getting rid of the parameter, this one will change slightly, but the rest of the steps will be exactly the same. So the first thing we're going to do is make our t, x, y tables. We've got t, x, and y. And on the unit circle, we're going to start at 0. And to make our points easy, to make our math easy, then we're going to pick the values where cosine and sine have nice, easy numbers to work with. And that just happens to be the pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to stick to those values. So we've got pi over 2, pi, 3 pi over 2, and then 2 pi. By picking the in-between values, you have more data points to plot, so you get a slightly more accurate curve, but we're still going to get the same thing by just picking the easy values. Alright, so if I take 0 and plug into the x equation, I'm going to get 5. And if I plug into the y equation, I get negative 1. Alright, so at t equals pi over 2, we're going to get the point 2, 1. At t equaling pi, we're going to get negative 1, negative 1. At 3 pi over 2, we're going to get 2, negative 3. And at 2 pi, we're going to get 5, negative 1. Alright, so we're going to use those data points to sketch our curve. Alright, so we're going on the x-axis, we're going from negative 1 to 5. On the y-axis, we're going from a positive 1 to a negative 3. 3, 4, 5. 1, 2, 1, 2, 1, 2, 3, 4. Alright, so let's plot those points. So I've got the point 5, negative 1. And so just remember that that was our starting point. We're going to plot 2, 1. We're going to plot negative 1, negative 1. 2, negative 3. 1, 2, 3. And then 5, negative 1 takes us back to where we start. Now this should be a smooth curve, so what we actually ended up with was a circle, which I'm going to redo because that did not go through any of my points. Alright, so and remember where we started and the direction in which we plotted. So we're going to draw in our arrows showing the direction at which my curve should travel. So that's showing the path there. Alright, so now let's write the equation by getting rid of the parameter. Alright, so what we're going to do here is, so let's start with x. Alright, so with the x equation, I can subtract 2. So I've got x minus 2 is equal to 3 cosine of t. I can divide by 3, so I've got x minus 2 divided by 3 is equal to cosine of t. Now the only way to get t by itself on this one is to do an arc cosine, or that inverse cosine. Alright, so we are, to avoid our equation getting so messy, which it's perfectly okay, you can do it that way, it just gets a lot messier. We're going to take the y equation, and we got the x in terms of cosine, so we're going to take the y and get it in terms of sine. So I'm going to add 1 to both sides. So I've got y plus 1 is equal to 2 sine t. I'm going to divide by 2, so I've got y plus 1 divided by 2 is equal to the sine of t. So I've got these two equations. And so what I want to do is just find an equation that easily relates cosine and sine together. Now the most popular one is one of our Pythagorean identities, so we're just going to do sine squared t plus cosine squared t is equal to 1. Right? So that's an equation that we know it's easy to work with. It relates sine and cosine together. So we're just going to plug in. I know that sine of t is 1 plus 1 divided by 2. So I've got that quantity squared, plus, I know that cosine is x minus 2 divided by 3, so that I have that quantity squared equal to 1. And so that is our equation. You could go about doing the arc cosine and arc sine and plugging one into the other. It's technically correct, it's just a much longer process. Alright, so here what we have are a couple of formulas that we need to make sure that we memorize. Alright, so the first one is going to be the first derivative, so dy dx. So I can take my x equation and find the derivative with respect to t, so that's going to give me the dx dt. I can take my y equation and find the derivative with respect to t, so that's my dy dt. And so if I do dy dt divided by dx dt, we can see that leaves us with dy dx. So that's our first derivative. Now, if we want the second derivative, the formula isn't just finding the derivative of the derivative. So the first thing you have to do is find the derivative of the derivative. And so that becomes our numerator. So the derivative of the derivative is the numerator, but then there's a second piece. You have to make sure that you divide by dx dt. So that's the biggest mistake that I see people make, is to forget to divide by dx dt. So to find the second derivative of a parametric, we're going to take the derivative of the derivative and then divide by dx dt. Divide by dx dt. Alright, so let's look at an example. Example 4. I've got an x equation in terms of t. I have a y equation in terms of t. So to start off with, let's just find dx dt and dy dt. Alright, so we know here that x is equal to 2t to the positive 1/2. So we're just going to do a power rule. So we've got dx dt is equal to t to the negative 1/2. We can find dy dt. So dy dt is equal to 6t minus 2. So we're going to use those two to help us determine dy dx and then evaluate at t equals 1, and then determine d2y dx2 and then evaluate at 1. Alright, so let's start with dy dx. So dy dx by definition is just dy dt divided by dx dt. So we've got dy dx is equal to, we've got 6t minus 2 on top divided by t to the negative 1/2. Now we can go ahead and clean that up a little bit. I'm going to divide each term by t to the negative 1/2. So when we divide like bases, we are going to subtract our exponents. So we end up with 6t to the positive 3/2 minus 2t to the 1/2. Alright, so that is our first derivative. If we want to evaluate dy dx at t equaling 1, so we're just going to plug 1 into that. So I've got 6 times 1 to the 3/2 minus 2 times 1 to the 1/2. I just get 6 minus 2, which is 4. Alright, so there's our first answer. Now what we're going to do is we're going to take and we're going to find the second derivative. So remember, the second derivative is going to be the derivative of dy dx divided by dx dt. So let's start by doing d dt of dy dx. So we're just going to take and use the form that allows us to use the power rule. Right, so that's going to give us 9t to the 1/2 minus t to the negative 1/2. Alright, so to find d2y dx2, we're going to take what we just found, so 9t to the 1/2 minus t to the negative 1/2, and divide by dx dt. So dx dt was t to the negative 1/2. So just like we simplified earlier, I can divide each term by that like base. Alright, so what I end up with is 9t to the first power minus anything divided by itself is just 1. Now it's asking us to evaluate at t equaling 1, so I can evaluate d2y dx2 at t equaling 1. So I got 9 times 1 minus 1, which is going to leave me with 8.